Simple Harmonic Oscillation, SHO, Complete Concept and Differential Equation Derivation. In this video, we explore the complete concept of simple harmonic oscillation, SHO, one of the most fundamental topics in physics. The lesson begins with the definition of SHO, explaining how a restoring force acts opposite to displacement and is directly proportional to it, following Hooke's law F equals minus kx. We then discuss the equation of motion, displacement, velocity, acceleration, time period, frequency, and energy conservation in oscillatory systems. Through clear graphs, viewers will understand the phase relationships between displacement, velocity, and acceleration. The video also covers important characteristics and real-life applications of SHO, including mass spring systems, simple pendulums, tuning forks, LC circuits, and vibration analysis. Finally, a step-by-step derivation and solution of the differential equation of SHO is presented using characteristic equations and initial conditions. This comprehensive tutorial is ideal for high school, college, university, and competitive exam students seeking a strong conceptual understanding of oscillatory motion. Short YouTube description. Learn simple harmonic oscillation, SHO, from basics to advanced concepts in this complete physics tutorial. Topics include definition, restoring force, equation of motion, displacement, velocity, acceleration, energy, time period, frequency, graphical analysis, applications of SHO, and detailed differential equation derivation with solutions. Perfect for HSC, undergraduate physics, engineering students, and competitive exam preparation. Keywords/tags. Simple harmonic motion, SHO, SHM, oscillation, harmonic motion, differential equation of SHO, Hooke's law, restoring force, time period, frequency, angular frequency, spring mass system, simple pendulum, physics lecture, engineering physics, oscillatory motion, SHM derivation, physics tutorial, university physics, classical mechanics. YouTube summary paragraph, differential equation derivation of SHO. In this section, we derive the differential equation of simple harmonic oscillation, SHO, using the fundamental laws of mechanics. Starting with Hooke's law, the restoring force acting on a displaced particle is proportional to its displacement and directed toward the equilibrium position, giving F equals minus kx. Applying Newton's second law, and equating the two expressions for force, we obtain m. To solve this equation, we assume a trial solution, derive the characteristic equation using Euler's formula. The general solution is expressed as xt equals acos, omega t, plus sin, omega t. Applying the initial conditions determines the constants a and b, yielding the complete motion of the oscillating system. This derivation forms the mathematical foundation of SHM and explains why oscillatory motion follows a sinusoidal pattern. Now let's derive the differential equation of simple harmonic oscillation. According to Hooke's law, the restoring force is proportional to displacement and acts in the opposite direction, so F equals minus kx. Using Newton's second law, F equals ma. This equation describes the sinusoidal motion of every ideal simple harmonic oscillator and serves as the basis for understanding oscillations in springs, pendulums, and many physical systems.